I'm very happy to introduce Mirella Lapata today for our distinguished data science lecture. Mirella is a professor in the School of Informatics at the University of Edinburgh working on natural language processing research. In particular, her research focuses on getting computers to understand, reason with, and also generate natural language. So Mirella is a super influential researcher. She's a fellow of the Royal Society of Edinburgh and has also received multiple Best Paper Awards in leading NLP conferences. So yeah, we're all very excited to hear about the movie analysis topic today. So yeah, Mirella, go ahead and take it away.
Okay, thank you so much for the introduction, and let me um, start. Okay, so the title of the talk is Automatic Content Analysis and Summarization via Turning Point Identification. Don't worry if you don't know what turning points are. I will explain them because they're quite critical to this entire movie analysis research program, let's say. The talk is split into three parts. So first I'm going to explain what turning points are. Then I'm going to show how you can use them to do this automatic movie analysis. And then the third part is how to use these turning points to actually do a task such as summarizing movies. And the last bit will be on actual video, not so much the screenplay, well, the screenplay as well, but the video too. Okay, and before starting, I should say that this is joint work with mostly Penelope, who is a final year student, and some collaborators are Leah Fairman and Frank Keller, who is in Penelope's thesis committee, and it all started with I suppose now old student of mine, Philip Gorinsky. This is when we first came up with the idea of actually analyzing movies and summarizing them and doing fun stuff with them. Okay, so why do we like movies? Why do we work on movies? So it seems to be the case that movies or films express something fundamental about human nature. This is a quote by Michael Dana, who is a Canadian composer, and here he's collecting his BAFTA or I don't know, some prize. And he says, "We love films and storytelling as a people. It's just a human compulsion to listen to and tell stories." So it seems to be the case, Michael Dana is telling us, that movies are a manifestation of telling stories. There is nothing controversial about this, and that it's in human nature, which is, again, not very controversial. We like reading books, we like telling stories, and movies are an extension of these. So all humans can watch them, all humans can understand them, and all humans can say things about them. Now, and movies are everywhere. And if that was the case when Michael Dana received his award, which is 20 years back, this is even more so the case nowadays with things that have to do with movies being all over the place. And we start with movie recommendation engines like Rotten Tomatoes. Rotten Tomatoes was launched, I believe, 20 years ago or even more, and now it has become like super successful. It is an online aggregator of movie and TV show reviews. So there is reviews from critics, but also from the audience, and there's like this review aggregation where you can get a one line that tells you whether the movie is worth watching or not, and it's reflected in these tomatoes that can be either green or red. Anyway, my kids nowadays say, it has like 70% on Rotten Tomatoes. This is very influential to tell you whether to watch a movie or not. And you can also read several gossip and news about movies. This is one setup where movies play an important role in making us decide whether to watch something or not. Another movie recommendation service that is less well known but has a kind of different functionality is Movie Lens. So I personally like Movie Lens. It is a different philosophy. It is not so much here's a review or a critic of the movie. It is more an actual recommendation system where you give the system a list of your preferences, movies that you like or you don't like, and then it sort of processes all of that and suggests new movies to watch. And this is based on personal preferences rather than what critics say. And it also gives you information as to whether the movie is based on a book or whether it's too long and too short. And somebody is doing this analysis, and it's a human in this case. Okay, so on the one hand, we all love movies, so there is the movie recommender systems. But of course, aside from reading things about movies, we can actually go and watch them. And this has become now the sort of Netflix and outfits like Netflix, Disney Plus, and Amazon Prime. And there is a huge availability of these online services where you can think of a movie and go and immediately watch it. And Netflix is a case in point. They boast 193 million users in approximately 200 countries. And they say that each one of the people, when you log in, you are served a different experience. And by that, they mean that Netflix itself will recommend you different things depending on the things that you've watched in the past. Now, I don't actually know exactly how Netflix's recommendation algorithm works, but they do have one. And it is true that I've tested it with multiple users. We all get different recommendations. Now, the fact that these movies are everywhere is great, but it actually comes with its own issues. So there was a study a couple of years back, and actually last year, not a couple of years back, 2020. And they found that the average household in America has 3 streaming services, not one, 3. And this is approximately, I don't know, 100 and something dollars to pay every month. This is an aside. 70% of the people polled said that they struggle to figure out what to watch. So there's so many movies, they don't know what to do. And not only that, it takes them 15 minutes to decide what to watch. So clearly, with all this, and it all adds up. So if you have 15 minutes to decide what to watch and your movie is 3 hours, then so you must be watching all day long. So we want to come in and help the user actually decide what to watch faster. And how could you hypothetically do that? So a user could ask things like, give me an alternative trailer for a movie. Or I want a 10-minute summary. I don't want to watch this, but I would quite like, some snapshot of what's happening. Show me action-packed shots to decide if I want to see this action movie. Or I want to see scenes with female leads. Or maybe just funny and happy shots. So you see how if we could do this, the experience of the user would be a lot better. It would be more personalized. But of course, this all assumes that, the machine understands the content of the movie pretty well. And we are not exactly there yet. Okay, so it turns out we are not there, and we're not there for a good reason, because analyzing movies is a super hard task. So if you like, movie analysis is a form of long form text analysis. And there has been some previous work on trying to do this from the perspective of summarization. So you have a long screenplay, you try to make it shorter, or question answering, where you have a very long movie, again, a script, and you're trying to answer questions about this, or even to generate the trailer for a movie in computer vision. There is some work there. The reason why this is all super hard is because movies are very long and complex narratives. They're not like stitched together. There's scenes, and scenes have dependencies. Movies are non-linear in the narrative sense, so there's flashbacks. So all of that have to be taken into account when you're analyzing the content of the movie. And of course, there is a computational problem that the models we have right now do not have good ways of actually, encoding these huge screenplays that are almost like a book. It's approximately 120 pages each. And you cannot even like do information retrieval. One may say, look, okay, it's too long, I cannot process the screenplay. What if I made it shorter? But then what is your query, and how are you going to actually find the things that you're looking into this very long? It's like looking for a needle into a haystack. So the task is actually really hard, and we come in here and say, okay, so yeah, it's very difficult. What if we impose some sort of structure on the screenplay or the movie later on, and use this as a first step to make the task more manageable? So rather than taking a large screenplay where you're trying to find information and it's all very difficult, what if we took the movie, the screenplay, and we identified the key events? And by key events, I'm talking about, you'll see what they are. There are these turning points, which I will explain in the next couple of slides. So if we could take the narrative that is in the screenplay and segment it into these events, then I will have some, at least, structure in this screenplay, in this sea of words that I can play with. And I'm sort of making the task more manageable. And also I have some analysis, some interpretation, because as we shall see, these thematic units have distinct semantics. They mean different things if you're in the beginning or the middle or in the end. Okay, so this is like a bird's eye view of what the approach is. So previous work tries to analyze these screenplays at a very sort of fine-grained level, where you identify characters and their interactions. And so you can think of C1, C2 here as different characters in the screenplay, and we impose a graph structure and they're all connected. And this is at the low level. What we are saying is, look, this is a screenplay. We're going to identify the main events there. And once we know these events, we'll take it from there. And so the question now becomes, what are these events? How are you going to find them? How are you going to segment the movie into these thematic units? And it turns out that we are in luck. This is something that people who study literature or create literature have been worrying about for a long time. And it all started with Aristotle, who said that any sort of narrative has this triangle structure that you see on the side. And so the theory goes that whenever you're writing a play or a book, you have to have this fixed structure where you start with the protasis. This is the beginning of the story, like, you know, the characters, an event that happened. Then you move on to epitasis, and this is the action. This is like the main bit of the story. And then things happen, they wind down, and you have the catastrophe, which is the climax and the end. So this is what Aristotle said, but it turns out that modern narrative structure theory thinks that Aristotle's triangle is a bit coarse-grained. So they tried, Freytag here, who used to be a German playwright, refined it into, and he took this triangle and made it into a pyramid. So now we have these different steps. We start with the exposition, which is again the beginning. The action rises, I have a climax in the middle, and then things start winding down, and I have the resolution. And this Freytag's pyramid is very important because it turns out it is the basis of the modern era's turning points theory that screenwriters use, and we will try to operationalize in this talk. So what are these turning points? So the turning points are based on this pyramid, and they're described as narrative moments. What does this mean? That as we watch the movie, something will happen that will move the plot forward. And so there's these moments in this, as time goes by in the movie, that happen, and then a different unit will start. So they are segmenting the events in the movie in different parts. And we are following this modern scheme based on this book by Haig that appeared in 2017 that assumes that the turning points are basically 5. And so I have an example here of the turning points, and then we will see how this applies to movies. I should say also that when you're becoming a screenwriter in Hollywood, and mostly I'm going to be talking about Hollywood. People ask me, what about Bollywood? I think Bollywood is similar, although I have no evidence to prove that. I should do the study on Bollywood movies. So in Hollywood, if you are a screenplay writer, a lot of them go by these 5 turning points. And in fact, there is entire treatises on the web as to how to write the best turning points in your story. So these 5 turning points you see here are the opportunity. So this is one point where an opportunity presents, followed by the change of plans, the point of no return, there will be a major setback, and then the climax, which will be the end of the movie. Okay, so that's what theory tells us, that every good movie should have them. And importantly, these are genre independent. So these turning points, the theory goes, should be the same in a comedy versus an action movie versus a mystery or a thriller. No matter what, you get these turning points. And they also say that, they have to happen at specific points in the movie. So opportunity, for example, is 10% of the movie in, you have to have the opportunity. It doesn't matter whether your movie is 3 hours versus 2 versus 1 hour. 10% of the movie, you have the opportunity. The point of no return is about half of the movie. And then the climax is about 80% of the movie in. So that's what they tell us. Okay, let's see a specific example. This movie, The Backup Plan. I do not particularly recommend that you see it. But it illustrates very nicely these turning points. So we start with Zoe. This is Jennifer Lopez, who has given up on love, and she decides to be artificially inseminated. And so the movie starts, and we see Zoe coming out of the clinic after she has done this in vitro fertilization, at which point she meets Stan, this guy there that you see in the picture, and this is the opportunity. So they like each other, they start dating, and Zoe finds out she's pregnant. Now, this is the second turning point here, which if you see here, it's called change of plans. Okay, so the plans change because, of course, her idea of romantic love cannot go on because she has to tell the guy that she's pregnant and with somebody else, not him. Anyway, so she tells Stan, and Stan is a really nice guy, and he commits to Zoe and the baby and says, yeah, great. And though now this is the point of no return, he's committed. He will raise this child, even though if it's not his. But then, because it's a romantic comedy, lots of things happen and misunderstandings. And you said, I said, they said, I saw you, I didn't see you. And lo and behold, they break up. So this is a major setback now. Oh my God, what is going to happen? But after a while, he realizes that she's the love of his life, and he proposes to her. And this is, of course, the climax. And at the end, we find out that she's pregnant again, this time with Stan. So this movie is very nicely illustrates how these turning points work. So our task here, what we want to do is to be able to identify these turning points in a screenplay automatically, and later on use them in video as well as text to be able to create a summary of the movie that somebody can watch. So this task, turns out, is relatively new. Nobody has tried to automate these turning points before. And so the first thing one needs to do is to create a data set where you actually have some annotation to do this. Now, I don't want to go on too much about the data set. The only thing I will say is that it was created by real people that were paid. They had real instructions. These are not Turkers. And it took us a while to standardize the instructions, and people agree and they do it very nicely, but it's not something that you can easily Turkify. On the positive side, these turning points annotators can actually identify, but there is a catch, and it's an important catch. And I'm talking about movies and about screenplays and about these turning points that happen at particular junctions in the movie. And think about the annotation task. If I have to have a lot of these movies, I have to pay a lot of money to a lot of people to actually read these screenplays and identify the turning points. And this can be a very difficult task because they are boundaries. So at some point, the turning point finishes and the new turning point begins. And trying to find these boundaries could be very difficult if you're doing it on the screenplay level. So what the annotation did is we actually gave annotators synopses, summaries of the movie, and asked them to annotate those as opposed to the screenplay. We don't particularly care about the synopsis, but we will see how we will transfer the annotations from the synopsis to the screenplay. The only reason one does the synopsis is because they're shorter and one hopes that people can agree at identifying them. I'll show you an example. Okay, so the annotation was on the plot synopsis level, and we assume that a single sentence is representative of a turning point. So all they had to do is read the synopsis and say, this sentence is a turning point, this is not a turning point, this is a turning point. And the rationale behind this is that we want to minimize the annotation effort and maximize the inter-annotator agreement. So this is an example, this is a synopsis, and you see the different colors here indicate different turning points, and the annotation is done on a sentence by sentence. Things that don't have color are not turning points. Okay, so we did this study, and there is a question, how do you measure whether annotators agree? Well, you can just count the percentage of cases where they select the same sentence for a given turning point. And in this case, you see it up here, it's 64%, which we think is good enough. So this is on a sentence level, whether they agree that this sentence is indicative of a turning point. We also annotated for evaluation purposes some screenplays. These screenplays will be used as test data, not for training. We will see how we will get the turning points for training in a bit. So we only annotated the screenplays for the movies in the test set, and the task was to find scenes in the screenplay that are representative of a turning point synopsis sentence.
Mirella, could I just interrupt?
Yes.
Yeah, there's a question about the annotation setup. So basically, are the annotators marking both the sentence as well as what function in that turning point theory they're like supporting?
Both. Yes. So here they would say, okay, the green is the first turning point, so this is, and they all go linearly. So the first one is the opportunity, the second one is the change of plans, the third one, and so on and so forth. Yes, so, but we know by position in the screenplay or here in the synopsis, which one is the first one, the second one, the third one. And you know that if you are like towards the end of the movie, none of the original turning points apply. They cannot happen, because if you're like 80% of the movie, you can only have climax and maybe change of plans.
Sure. And a follow-up question to that.
Yeah, of course.
Do you think for some less formulaic movies, there could be an advantage to just detecting major plot events outside of this turning point structure, or is this sufficient for most movies?
Okay, this is a brilliant question. I would say that if you talk to any Hollywood person and to people who actually have written screenplays, they all swear by this. Having said that, though, there are particular movies, art house and whatnot, that do not subscribe to these turning points. Also, it is very difficult to do this if you have flashbacks and you go back and forth and it's non-linear, I will say, or movies like Memento, where it starts from the beginning, where the end, it's reverse chronological time. So no, but I would say that it covers the majority. And of course, I don't know how these work if you have series and blah, blah, blah. The theory is it should work for everything. My gut feeling is, and from what we've seen is 60% of the time, it's good enough. But for example, nowadays there is movies, like go find in Marvel movies, the ones that last 3 hours, these turning points. It will be very difficult. And if your narrative has like many subplots, also very hard.
Okay, thanks. Oh, I get maybe one last question just
Of
popped up.
course, of course.
Brent, do you want to just ask the question?
Sure. Hi, Mirella.
Hi.
Since you mentioned that these turning points, according to the theory, come at kind of typical moments over the course of the movie, like the opportunity at 10% and et cetera and so forth. Are those kind of percentages also found like in these synopses? Like, could you almost guess, like, you know, whether it's bag of words or count the sentences, like the 10% sentence of the synopsis roughly is going to describe the opportunity?
Yes, yes. And these are baselines we all have. Yeah. So you have any kind of automatic thing you may have needs to do better than this position. We call it position baseline. And this is correct. Yes. And the assumption is that the synopsis also behaves the same, mirrors what the screenplay does. And in most of the cases, it is the case. But, agreement is 60%, which means that there is a bit where people cannot identify these things reliably because they don't expect them to be there. And we've seen this. I've annotated some of these myself. So in most of the cases, it works fine, but there is a small majority. I remember there was a movie about the future and some monsters. This was impossible to do. So, it's a creative process, and we can streamline it as much as we can, but there will always be outliers.
Very good. Thank you.
Okay, so now remember what I'm saying. We are doing synopsis, and we actually care about the screenplays. So, and I also said that we annotated, yeah, here I am. Okay, so we annotated some screenplays in the test set to be able to evaluate. Okay, I told you the task is impossible. It is impossible when you have 200 movies. If you have 50 movies, it is a bit more manageable. And now we are making an assumption here, and this is kind of important for the rest of the talk. We are assuming that a scene will be representative of a synopsis sentence. So what we're going to do is we have this sentence annotation, right? And we're going to ask now people and the models later on to take these sentences that are supposed to represent a turning point and find the scenes in the screenplay that correspond to these turning points. And you can already think in the back of your head, okay, so this can be an IR type of thing where I have the sentences and I'm trying to find the scenes, which are like big blocks, and every screenplay is segmented into these scenes. This is important because the director needs to know where things happen. So the scene will say, this is an exterior scene, and, Mirella and John are sitting outside drinking coffee. Mirella is looking mean and John very sad. So we know what the scenes are, and we will try now to map them on these synopsis sentences that are the turning points. So it will look like this. We have a turning point here that an annotator has annotated in the synopsis, and we're trying to find the scenes that correspond to this turning point. And it's important to note also that it's a one-to-many mapping, so there can be several scenes here that correspond to this one sentence, which is reasonable because you're trying to compact an entire movie into one sentence, so there can be many scenes that talk about this turning point that changed the course of the narrative. Okay, I'll mention one more thing about agreement, because these agreements we're going to use to also evaluate what the model is doing. So now we don't have sentences, we have scenes. So the interannotator agreement is the mean of the distance between the gold synopsis scene and the annotation that the annotator is doing. So here we take the mean of these differences, and they're normalized by the length of the screenplay. So what would perfect agreement be? There would be no difference between the two annotators. So S and G are the two annotators annotating things. So if me and another annotator agree completely, the distance would be 0. So we want to be as close to 0 as possible. And you see here, the agreement is 1.48%. So they're 1.5 on average seems off, which is good enough. It means that, you know, at least the location in the big screenplay of where the turning point happens is nearby. If it was like very high, the inter-annotator agreement, if the distance was 5, it would mean that, you know, there is no agreement whatsoever. Okay, so now let me talk about the modeling bit. So we want to identify, so the first task would be what you guys asked me, can you identify these turning points in these synopses? So this is the first thing. So first we're going to see if we can actually find them in the synopsis, and then we will see how we will identify these turning points in screenplays. And once we've done that, we're going to move to video and see how we can summarize it. Okay, so here's like a simple model you can think of. These plot synopses and their annotations are the training data. And so you create a sentence encoder using whatever embeddings you want to have these days for your sentence, word embeddings, and you just output prediction Y. And this can be phrased as a binary task where 0 means no turning point and 1 means there is a turning point, and we know the ascent in order. So if we see our first sentence is 1, then we know it's the first turning point, and if our fifth sentence is again 1, we know it's the second turning point, and so on and so forth. So we are doing this binary classification task per sentence. And this could be your vanilla model, and you can have like a perceptron or whatever unit you like on top of this embedding. So this is like a very primitive model. Then you can run an LSTM and contextualize these embeddings and be done with it. So we start from sentence encoding to contextualized sentence encoding with a BiLSTM, and you could even use transformers, although the benefit of transformers is not that huge. We have run these experiments and I can explain why. Ask me in the question time. And you could be done with it, but we'll do one more task, one more thing in this model architecture, which turns out to be very important. And this is this context interaction layer. And I'll give you the intuition for this, and then I will show how we do this. So remember that these turning points are basically segmentation boundaries, and they happen between like as we go linearly through the synopsis and the sentences, we just need to insert a boundary and say there is a new turning point. And so if you think about it like that, this is a segmentation task. And the model so far has no notion of how the topic changes from one sentence to the next. And so we are trying to instill in this model this knowledge of, topic changes, a bit like textiling, if you remember what that was. So here's how it happens. So we have these turning points that are key events that happen at the boundaries of sentences, and we need to express whether a given sentence is similar or different from its surrounding context. So assume here I want to build a representation for X3. In this case, I will take the left context and I will take the right context and I will average them together. And this is a representation of its context. And I have a sliding window so that I will do it for other sentences as well. And once I encode the left and right context, then I will estimate the similarity between the left context and my X3 sentence, and the same for the right context and my X3 sentence. And I will take these similarity values and I will concatenate them with my representation of X3. So this tells me the context is similar or different, and then I will use this enriched representation to make this prediction. And this is the context interaction layer, which is a fancy term for telling you that I am taking the similarity of the current sentence with its neighboring sentences into account. Okay, and one more thing you can do is instead of actually having one big fat model to represent all the turning points, you can have individual models for individual turning points. This is this multi-view TAM, and this also makes sense because you have like different views of the synopsis, and then you take the representations for the different turning points and you merge them together, and you give this merging layer to your, to your neural network that makes the final prediction. And it will be no surprise, we have a very similar architecture to do the same task on the screenplay level. Okay, so here's the task then for the screenplay level, a turning point identification. I have a synopsis, and the synopsis has turning points in it, and the turning points can be gold standard or predicted. And I will show results with both gold standard turning points and predicted turning points, and it will be no surprise that gold standard is better than predicted, but we really are interested in an end-to-end system where the turning points are predicted. So I start with my synopsis, I predict the turning points, and then I have to find these scenes in the screenplay that represent these turning points. And if I find these scenes here, I will just project the label and assume that if the two are similar, if the turning point in the synopsis is similar to a scene in the screenplay, then the screenplay bears the same label. And so it's a bit reminiscent of annotation projection. Now, in the screenplay level, when I'm doing this now with a lot of text, and I again will have my plot synopsis, and I will have the screenplay, and I will encode them both using whatever encoder you like, whatever embeddings you like. We use for the plot synopsis and the screenplay these use embeddings, which perform best than anything else we tried, but this is not important. You can use whatever you like. And again, we're going to have our synopsis encoder and a screenplay encoder where we encode these sentences. And on the plot synopsis side, we also have the turning points, and we will measure the similarity between the sentences in the synopsis and the scenes in the screenplay encoder. Now, what's missing here is that I will have again, a context interaction layer on the screenplay, and it's the same idea. We're going to look at neighboring scenes and how related they are to the scene we are looking at time t. So at the very end, once I have these representations, I have a representation of the sentence and a representation of a scene, I will just measure the similarity between the synopsis turning points against the screenplay scenes, and if they're very similar, I will project the labels. And this is what this means here, turning point scene interaction layer. Whenever you see interaction, think similarity. Okay, and then I'm done. Then I can train the model and predict the turning points on the test data. Now, I will show some results, and then I will pause for questions before I go to the other part of the talk. Okay, so how well are we doing at identifying these turning points in the synopsis? So this is on the sentence level. And we start with the human agreement, which is 64%. This is the same, this TA stands for total agreement, and it's the same metric I'm going to use for all the models. So 64% is the upper bound, and you see the random allocation is 2%. The theory baseline is assuming positions, like the 10% of the movie will be the opportunity, 50% of the movie will be the point of no return. So this is taking the positions that the theory tells us. And distribution baseline is the same idea, but we are actually measuring these positions on the training data. So it's it does better and it's more informed. And Multi-view TAM does better than the baselines, but perhaps not unexpectedly, a lot worse than the humans. We also gave these things to humans to assess. Let me actually take you through this graph. So we gave humans the synopsis and annotations of turning points, and we asked them to actually rank these and tell us this identifies the turning points well, bad, or whatever. So we created a ranking among systems, and you see that when you give them the gold standard, the majority, which is this dark blue, ranks it first and followed by second and third, okay? When we give them our model multi-view TAM, in the majority of cases, it is ranked second, so they prefer it after the gold standard, and the distribution baseline, most of the cases, is ranked third. So this is good. It means that the humans corroborate the automatic results. But in reality, we don't really care about the synopsis. I just want to play with the screenplay. This is the movie. It's not the synopsis. So what happens when we are trying to identify these scenes in the screenplay? Now, you see here the human agreement. So now I'm changing the metric. This is not anymore this total agreement. It is the distance, because remember, I have these big scenes and I'm trying to find boundaries, and it's a very difficult task. So humans are doing quite well, 1.48%. And these are the baselines. So we have the theory baseline. So basically they're 10 scenes apart on average, not great. Then we have the distribution baseline, again, very bad. And we also did a TF-IDF baseline where we used the sentence as a query to retrieve a scene. And this performs really poorly. And there is a very good reason why. There is not enough information. TF-IDF thinks every scene is relevant. Words are repeated. The sentences, you basically cannot discriminate. There's a few words in the sentences that the query basically that are repeated throughout the screenplay, and so it thinks that many scenes are relevant, and that's why it does so badly. And here is TAM. This is the model that I showed to you that doesn't do exactly like 1.48%, but better than the baselines. And if you do a fully end-to-end system without gold standard annotations where you predict the labels on the screenplay, it's expectedly worse, but still a bit better than the baselines. Okay, I have some examples to show here, and then I'll pause for questions. So this graph shows the movie Juno. These are the scene indices, so the number of the scenes in the movie. And you see that there's a lot of scenes, more than 100 scenes. And the different dashed lines indicate the different turning points. So these are gold standard turning points, and you want a model to hit these. I mean, not exactly, but you want them to be in that area. And I'll show you how the distribution baseline does. So you can see the distribution baseline is not terrible. So it sort of misses the first turning point here, but it hits the second one. Again, it misses the third one, and then is right there on the fourth, and it's doing okay with the fifth turning point. So this is a good prior to sort of use in models, and also this is not a Stroman baseline. Let's look at TF-IDF. TF-IDF is all over the place. Basically, it cannot discriminate the scenes between them. And this also shows how difficult the problem would be if you were to handle it from an information retrieval perspective. You basically cannot find the relevant scenes. And finally, our model. So our model also has difficulty with the first turning point. It sort of hits the second one, hits the third one, fourth one, and does okay with the fifth one. And you see the boundaries are a bit wider with this model, which is what you want. You want to hit the turning points rather than miss them. Okay, So far I've talked about how we identify these turning points in screenplays. We're assuming that the different turning points represent major events that happen in the movie, and they help us segment the narrative into thematic units. And you can see already how you can create things in a more personalized vein. You can only, for example, show to somebody the opportunity, or you can only show them the climax, and so on and so forth. So you have already more information. Now, movies are not screenplays. Movies are movies. And so the next bit I'm going to talk about is going to be about using multimodal information and actually using these turning points to do something like movie summarization. And I'm going to stop here, see if there are any questions, and then we're going to go to the second part of the talk, which I promise is a bit shorter because I've introduced everything, so it will go by fast. If there are questions, if not, I can just continue.
There's one quick question in the chat. Can documentaries also fit into the turning point theory?
Yeah, I think they would argue. This is a brilliant question. I think they would argue yes, because they have to tell a story. And the theory goes that every story has to have like these points. However, I think the climax, like the final turning point, would be fine. The beginning would be fine. The problem would be, as always, with the middle bits, like a point of no return. And where is a climax in a documentary? It's not clear to me. It could be that with documentaries, you have a more coarse-grained structure, basically, the problem, what people are doing about the problem, and then, doom and gloom in the end, how humanity will be destroyed. So I have not done this, but I would expect that there will be some narrative structure. It may not be exactly the same.
Okay, great. Yeah, I don't think there's any.
Okay, so let's move on now to movie summarization. So remember, all I've talked about is on text. Now we're gonna look into video as well. Now, how are we going to formulate the summarization task? So it's very simple. We will see movie summarization as scene extraction using these turning points. So for each scene in a screenplay, and by that scene in a screenplay, I mean scene that has also video with it, we will assign a binary label that denotes whether it represents a turning point or not. So we will use the model I showed you before, this topic-aware model, to compute the probability of the label given the scene. And now, once I have scenes and labels that tell me, is this scene a turning point or not, it's trivial to produce a summary. I will just take these turning points, concatenate them in order, 1, 2, 3, 4, 5, and I can play you a summary, which is more or less 10 minutes. And this is something that you can manipulate, the length of the summary. And my job is done. And so what I would say is that these turning points are great. Not only they allow you to do analysis of movies, I have examples at the end, and sort of see if they have the same morphology. Do all action movies have the same turning points? How are movies different across genres? You can answer these questions, or at least ask them and attempt to answer them. But also, this is a very data efficient way. I don't need extra data sets to do summarization. Once I have the turning points, I can naturally generate a summary. So let's see how we will do this. And there is a problem, which is that so far I'm assuming a simple linear structure. And I'm not happy with this because movies are not linear, and because there's dependencies between scenes. Everybody who has seen like a murder mystery or whatever, they give you these clues that happen in the beginning, and then at the very end you realize connections. So there are connections between scenes that are definitely not linear. And the idea is to use a graph to compute this probability of a turning point given the scene. And I will assume that nodes in this graph are going to be my scenes, and the edges will represent the similarity between those two scenes. And here I'm going to use both textual and audiovisual information. So you understand why text might matter, but also why the audiovisual features will bring something into the mix, because at least you know you're in the same room. Music turns out to be very important in movies, so we want, if the movie is if the music is intense, something's going to happen. So we want to tap onto that and have like all of this information in the graph. Okay, so this is an overview now. So this is conceptually a simple system. So we have the screenplay and the video. We will take this screenplay, which has scenes, and turn it into a graph. And once we have this screenplay graph, we will use it to produce predictions about turning points. So the model now slightly changes. It's not this sequence by sequence by LSTM. We have an underlying graph, which I will have to encode somehow to make predictions. And once I have these turning point identifications, I can produce a video summary by traversing here the scenes and concatenate them together, the scenes that have been identified as turning points. Okay, so how do we do this screenplay graph? So we start with a fully connected graph. And we use textual and audiovisual similarity between the scenes to estimate the edge weight. Now, once we have this fully connected graph, we will sparsify it by selecting the top K neighbors of each scene. And this is again very important because we want to be able to, sparsification is important because we want to be able to compare movies. And if they're all fully connected and all the graphs are like similar to each other, I'm not going to be able to discern differences. So we sparsify the graph because we want them to be sparse to detect differences, but also computationally, it's better to have like less connections. So we will select the top K neighbors for each scene. And once we do that, we will encode this sparse graph in a graph convolutional network. And so we have this encoding of the graph, and to get a representation for a scene, I will concatenate the scene neighborhood representation, which will be computed by the graph convolutional network, with a scene content representation. And by that, I mean with the BiLSTM we've seen before. And then we use a classifier to spit out the probability of having a turning point given the scene. I have a figure here. So this is the input. This is a screenplay. I have the scenes here. I compute the pairwise similarity. This is the fully connected graph. Edge weights are the combination of textual and audiovisual similarity. Then I will sparsify this graph by selecting the number of neighbors per scene. And this is done automatically as part of the learning. So we don't actually have a threshold saying that every scene has to have a fixed number of neighbors. The neighbors are between 1 and 6, but the number of neighbors per scene varies, and this is learned. Once I have sparsified the graph, I will use a graph convolutional network to represent this, and this representation, this GCN representation, will be concatenated with the BiLSTM you've seen before to create these representations of the scenes. And then I will do the prediction task like I've shown you before. So a little bit more complicated, but I think this makes a lot more sense than before because it acknowledges the fact that there's dependencies between scenes and that things don't progress linearly. Okay, so I'll show you first how numbers differ when you use this graph and audiovisual information to compute the turning points. And then I will talk about summarization results. So again, we have a total agreement and this distance level metric. And you see we are comparing the random baseline, the theory baseline, and the distribution baseline. These are the things that we had before. And now I have two models here that are well known in summarization. This is text rank. This is an unsupervised model enhanced with audiovisual information. And SynSum, this is a model that performs summarization on screenplays, but has a different assumption. It assumes that it creates graphs per important important protagonists in the screenplay. So it is person-centric as opposed to scene-centric. So the graph will be all the main characters of the movie, as opposed to we have a graph of the scenes in the movie. And then we have the previous model, TAM, with audiovisual information, and the graph model with audiovisual information. The baselines, we cannot do audiovisual information. It's not clear how you do it, so it's just text. What you can see here is that TextRank and SceneSum do okay with agreement, but the distance is terrible. That means that they never find the scene with the actual turning point, or even the region with the actual turning point. TAM does better, admittedly, but Graph TP is bringing improvements over and above the previous model. And this is encouraging. It means that the graph information gives you something. But this is just to verify the fact that turning points make sense and that, you know, the model makes sense. I won't go over this slide. I've just said this. Let's look at the summaries and see what we get. So what do we do? How do we evaluate these summaries? So the output of this model that I showed you here is just turning points, scenes that the model thinks are turning points, and I can paste them together and then I can show them to people. So what did we do? So a summary will contain 3 consecutive scenes for each turning point. And this is around 10 minutes total length. And we give this to people. We give we give this summary, and the person sits and watches the summary. And then you ask them to decide for each summary whether it contains correct information for each turning point. So they would read, and we would ask, does this summary contain information about the opportunity? Here's how opportunity is defined. Does it contain information about change of plans? And then they would have to say yes, no, and also at the very end, rate the quality of the summary. Did they like it? Did it make sense to them? We also had some questions to make sure they watched the stuff. It was quite elaborate. Anyway, so what you can see here is how the different models are doing per turning point. And overall, so if you don't care about the individual turning points, I'll turn to them in a minute. You see that GraphTP is doing much better than TAM on the actual task. These models were not very different when you do automatic evaluation, but actually when you show the summaries to people, there is a substantial difference. And GraphTP is okay. It's almost, you know, it's approaching gold standard performance, which is never going to be perfect because summarization is a very subjective task. Now, interestingly, we can also see which things the model is doing well or badly. So opportunity is fine, change of plans is fine, point of no return, not so fine, major setback, okay, climax, very difficult. And I observed this myself. I could never hit the climax right. It's difficult, in particular in action movies where there's so many things happen and they're all very similar. And as for the rating, no surprises there. SceneSum and TAM are almost indistinguishable. GraphTP is better, and of course the gold, much better. Okay, so why do we bother with this graph? And I want to say that this graph is actually really important because it can allow you to understand what the model is doing and interpret its behavior. So this graph here shows different turning points, x-axis, and the average node connectivity. So how connected is one node to the other nodes in the graph per turning point, and also for different movie genres. And so we have 4 coarse-grained movie genres. This is comedy and romance, action, thriller, and drama. And I want you to look at this graph for a bit, not that long. And we can see already that there are substantial differences across genres depending with regards to the connectivity. So, for example, the graph starts being fairly not very connected in thrillers. And then suddenly, because, there's all these disconnected things happening and connectivity increases the further we are in the movie. Now, the sort of opposite happens with action movies. Action movies, you start with things being very connected. Everybody knows everybody. Lots of things happen. Uh, explosions, revelations. There is a lot of connectivity. There is the same people all over again. But then suddenly connectivity drops because we know everything, and so there is no more links to the past. What else is interesting? The same is the case with drama. Drama starts very connected and then it becomes less connected. Whereas with action, we observe that, connectivity increases. So we can make such observations about the different genres. And these are also borne out when we analyze individual movies. So here's the movie, the graph, the screenplay graph, which it's a bit simplified because all the nodes wouldn't fit in the slide, for the movie Die Hard. So this is an action movie, and you see that there's a lot of connectivity. So a lot of things are interconnected because, there's protagonists, there's action, some people may die, but not much else differs here. Contrast this with a movie like American Beauty, which is a drama, and it has a lot of flashbacks. In fact, it starts with a flashback, and this is a lot less connected because it's a very different movie, a different genre, and it also shows that its narrative structure is very different. Okay, this is, I think, the final slide. So what have I talked about? I've introduced this task of turning point identification in screenplays, and I assumed that we can identify these key events in screenplays, and these will allow us to segment the narrative into these thematic units. The graphs are useful because they're useful for many reasons. One is that they can naturally incorporate through the similarity, similarity function, audiovisual information. They can be used for movie summarization, but also more importantly, they support content analysis, as I've shown you with the different genres. And what we're trying to do now, and I think it's quite ambitious, is we are trying to take this framework with the graphs and actually formulate it such that we can not generate a 10-minute summary, but generate a 2-minute trailer. And this assumes that we reformulate all of that on the basis of shots. And shots are like 1 or 2 seconds each. So you get these very huge graphs with many connections. And, this is another talk. And I'll stop here. Thank you so much for listening to me. And I can take questions if there are any.
Great. Yeah, so thanks a lot, everyone. You can unmute and applaud if you want.
Thank you.
Great. Sorry, I muted myself. We have a couple of questions for those of you who can stay later. Why don't you just unmute and go ahead and ask yourself as opposed to me reading them? So Juan Yuan, do you want to go first? Okay, maybe I will just read this question.
Just read, yes.
All right, so the question is, how well does the context interaction layer, does the similarity between sequential sentences provide different behaviors for specific turning points?
That's a beautiful question. So yeah, so we have done some analysis. it's a very good question. So it only differs with regards to the climax. So it doesn't actually seem to work very well in the climax, which is problematic. You saw the models have difficulty. And also sometimes it struggles with the opportunity, in particular in genres like drama or action, where the opportunity is more subtle. In comedies, the opportunity is bang there. You saw the example with Jennifer Lopez. The opportunity is very clear because this is the interest, the love interest and whatever. In some other genres, though, it's much harder. And there, of course, the similarity also has problems. Because let's face it, the stuff is actually quite crude. It's like embeddings and it's all based on lexicon, and we don't actually know who are the protagonists. I mean, there's a lot more that we can do. There's no co-reference, blah, blah, blah. I can go on.
Great. And Varun has a question. Do you typically see particular tropes associated with each turning point? I guess this is dependent on the genre. Probably.
It depends on the genre, but yes. And I should show these figures in future renditions. Yes, exactly. So for different genres, we see different tropes. Some genres are, the other problem is that nowadays Hollywood is trying to be cute, and they don't have, like, there are many movies that have multiple genres in one. And there, this whole approach is a bit problematic because a movie can be a little bit of drama, a little bit of comedy, and a little bit of action. And maybe a thriller on top of that. You know, it's like Parasite, the movie Parasite. The model has real issues with this because it doesn't have a definable genre. And yeah, the tropes there would be difficult.
Okay, great. I don't think we have any other questions. So thanks again.
Okay, wonderful. Thank you. And for the meetings and for hosting me. And hopefully I'll see you at some point live.